So welcome to today's lesson. Today I would like us to learn sigma notation. We are going to have some three objectives of the lesson. One of them, we are going to learn how to use the sigma itself. We are going to do a couple of examples there. Then we shall also learn how to evaluate sigma from n equals 1 to n, where n is a large number. So we shall be speaking of situations where n is equals to maybe say 30, 40, and on and on. And lastly, we are going to learn how to evaluate the sigma from n is equals to k to n, where k is not equal to 1. Some of these things are going to make sense as the lesson goes on. So let's start us off with how to use sigma notation. Let's first of all start with how to use sigma notation. And I'm going to start off with what is sigma. So sigma is basically summation. We are going to be adding terms in this lesson. So let's deal with some examples. If, for example, you are given evaluate sigma n from n equals 1, maybe say to 5, what are you supposed to do? Let's see. So you are going to substitute this n with the values 1, 2, 3, 4, up to 5, as you can see here. Sigma of n from n equals 1 to 5 is going to be, when n is equals to 1, you just be having 1 there, plus when n is equals to 2, plus when n is equals to 3, plus when n is equals to 4, then lastly, plus when n is equals to 5. I'd like you to notice we have started with the first value of n being 1, and we have listed without skipping any up to the value of n equals 5. So let us determine what this is. 1 plus 2, that's 3, plus 3 plus 4, that's 7, plus 5. So 3 plus 7 is 10, plus 5, that is equals to 15. There is no fanfare, it's just a matter of finding those values over there. Hope you are followed. Let's work with a second example. So let's say you have 2n, evaluate from n equals 1 to 5, 2n plus 5. As you have seen the previous example, the value of n is going to vary from 1 to 2 to 3 to 4 all the way to 5. So the solution of this is going to be the summation from n equals 1 to 5 of 2n plus 5 is going to be 2 into 1 plus 5. That whole thing you add 2 into 2 plus 5. That whole thing you add 2, that's greater unit 2 into 3 plus 5 plus 2 into 4 plus 5, and then plus 2 into 5 plus 5. So you can see we have listed 1, 2, 3, 4, 5. We have substituted this n with a 1, with a 2, with a 3, with a 4, and with a 5. So what do you get? This becomes 2 plus 5, which is just a 7, plus this becomes 4 plus 5, which is a 9, plus this becomes 6 plus 5, which is 11. This becomes 8 plus 5, which is plus 13. And this becomes 10 plus 5, which is just going to be plus 15. And the final answer there is going to be 7 plus 9, that's 16. 16 plus 11, that's going to be 20. That's going to be 27. 27 plus 13, that's going to be, let's work it out slowly. 7 plus 9, that is 16, plus this is 24, plus that is 15, and that is going to be equal to this plus this, that's going to be 40. So that's going to be 55. Hope you have understood what we have done there. Now I'm going to give you some exercise. So I'm going to give you just some 3 examples. So exercise 1, evaluate the following. A, we are going to have the summation from n equals 1 to 7 of n minus 10. Then B, we are going to be having the summation from n equals 1 to 10 of 2n minus 3. Then lastly C, I'm going to have the summation from r equals 1 to 5 of 2r squared. So you can see here, this is r and this is r. That's how it goes. Okay, so that is the first objective that we have successfully worked on. So let's get to the second objective. The second objective is going to be how to evaluate the summation from n equals 1 to capital N of a certain function where n, capital N, this value here is large. And again here, I'm going to work with an example. Assume you want to evaluate, I have some worked out examples here. Assume you want to evaluate the summation from n equals 1 to 70 of 2n plus 5. You'll agree with me that it's going to be quite a huge task to list n1, n2, all the way to n70. And therefore it will be necessary for us to come up with a strategy. But I want us to make a certain observation. This is going to be 2, 1 plus 5 plus 2, 2 plus 5 plus 2, 3 plus 5 plus 2, 4 plus 5 plus many others. And the 2, 1 plus 5, that's going to be a 7. And 2, 2 plus 5, that's going to be plus 9 plus 11 plus 13 plus many other terms. Now, this looks like it's an arithmetic series. Why? It looks like you're adding 2 every time. The difference between the two is, between each of these is 2 all the time. And therefore, this is an arithmetic series. Arithmetic series with A equals 7 and D equals 2, because the common difference is 2. And therefore now we can be able to work this out using this observation, using this idea. That means therefore we are just going to get S70 being the sum of the first 70 terms, which is going to be equal to 70 over 2 into 2a, which is 2 into 7, plus n minus 1, which is 70 minus 1, multiplied by d, d here being 2. This is a big bracket there. Now this becomes 35 into, this is just going to be 14, plus, going to be 69 times 2, 140, 138. So this is going to be equal to 35 multiplied by, this is 180, no, 152, 152. And therefore all we need to do is to multiply this 152 multiplied by 35, which is going to be 6 there, 15, carry 1, 4. You're going to be having a 10 there, carry 1, 26 there, carry 2, 7, and the other going to be 0, 2, 3, 5. So this is basically 53, 20. Note, sometimes you'll be getting a geometric series, in which case you're going to be using the summation formula for the geometric series. So work with whatever you get. All right, it's time now for me to give you some questions there. This is going to be exercise 2, and I forgot to change this to a 2. So exercise 2. Evaluate evaluate the following. A, we are going to have the summation from n equals 1 to 40 or 5n. Then B, we are going to be having the summation from n equals 1 to 20 of 3n minus 2. Work on those and see how it goes. Now, the then objective. So the then objective is going to be how to evaluate this kind of a thing, but this time round we are starting from a k. We are starting from k, so we are not starting from 1, where this k is not equal to 1. I'd like us to see what we can do over there. So, if you are given in general, if you have the summation of a function f of n from n equals k to a certain value, now what we do, and k is not 1, what we do is we get the summation of the entire function f of n from n equals 1 to that capital letter over there. Then we subtract the summation from n equals 1 to k minus 1. So whatever this k was, you just do all the way to k minus 1. And we are gonna deal with an example over here. So let's work with an example. Evaluate. This is an example. Evaluate. The summation from n equals 10 to n equals 70 of the function 2n minus 5. Okay. So from what we have seen that the summation of f of n, let me just say the function that we're having here, the summation of 2n minus 5 from n equals 10 to n equals 70 will actually be the summation from, or rather of 2n minus 5 from n equals 1 to n equals 70 minus the summation from n equals 1 to n equals k. This is a k, 10 minus 1, which is a 9. So this is 2n minus 5. Now if you look at this closely, this is actually going to be S70 minus S9. Now, let's study this so that you can see that it's forming an arithmetic series or a geometric series. So when n is 1, this is going to be negative 3. When n is 2, this is going to be negative 1. When n is 3, this is going to be a 1. When n is 4, this is going to be 8, 3. Now, looks like we are adding, we are doing plus 3, plus 3, plus 3 each time. And therefore, it's an arithmetic series where A is equals to the first term, negative 3, and D is equals to 2, rather plus 3, the one that we are adding. And therefore, this could be 70 over 2 into 2a, which is 2 into negative 3, minus n minus 1, which is going to be 70 minus 1 into brackets d, which is 2, that whole thing, minus, now s9, that's going to be 9 over 2 into 2 into negative 3 one more time, plus, this is a plus, n minus 1, and the n is 9 minus 1 into brackets d, which is still a 2. Okay, so not much fanfare here. It's just a matter of working out this one here. This is going to be 35 into minus 6 plus, it could be 69 times 2, which is 138, minus, this is going to be 9 over 2, let it just remain being 9 over 2, into minus 6 plus 8 into 2, which is going to be plus 16. Now I don't have much space here, so I'm going to do the working of this one right here. Now minus 6 plus 132, I mean plus 138, that is just going to be 132, and minus 6 plus 16, that's going to be just plus 10, or just a 10 there. When you multiply this, let's multiply it somewhere over here. 132 times 35, 132 times 35, we're going to be a 6, we are going to be having a 9 there, we are going to be having a 3 there, we're going to be having a 10 there, carry 1, 15, 16, carry 1, 6. So we add them, we are going to get a 12 there, we are going to get a 16 there, we are going to get a 4 there. So this is going to be 4620. This is going to be 4620. 4,620 minus, now this is going to be 45, because by 2 1 by 2 5, so minus 45. That one is done and dusted with. Now let's subtract 4620 minus 45. Then going to be a 5, going to be an 11 7, then going to be a 5, going to be a 4. So this whole thing is going to become 4,575. That is what this gives you. Hope you have understood. Just study this example. If need be, go through it one more time, watch it, and when you feel comfortable, you can then do the following exercise. So exercise, this is now exercise 3. Exercise 3. Evaluate the following. Evaluate the following. You're going to be having the summation from n equals 20 to 70 of n minus 8. That's going to be the first one. The second one is going to be the summation from n equals 35 to 100 of 3n minus 1. Now, as you do this, recall, I'm just going to give you a recall that the summation from n equals k to n of f of n is going to be the summation of f of n from n equals 1 to capital N minus the summation of f of n from n equals 1 to k minus 1. Just do not forget that. So remember this. Now that brings us to the end of this lesson. See you in the next lesson. Bye bye.